Hi, welcome back to hostboxcse channel and back to the tutorial for tutorial for computer architecture and organization. This tutorial definitely help for clear the GATE UGC NET and some of the competitive any kind of competitive university and some of the college level and university exam also. Let's go for session today. Today we are going to see the topic called what is hazard in pipelining and what are the types of hazards in the area of computer architecture and organization. So in the previous session I explained about the pipelining versus non-pipelining. What are the difference between pipelining and with the non-pipelining, and also some pipeline processing, entire process, the example. I hope that you understand this, and please kindly support the channel and kindly watch the playlist, then only you will get the continuations of the topics and syllabus what was discussed in the previous sessions. Let's go over session today. First you have now what is hazard. What is hazard in pipelining? You can say simply it's an any condition that causes a stall in pipeline operations. Any condition that causes a stall in pipeline operations are called a hazard. So pipeline is what? Some of the condition it may stop your process. Instruction will be executed with the help of 5 phases. We already discussed fetch, decode, okay, operand code, fetch, decode, and so on continuation. And hazards are one that arise in the pipeline prevent the next instruction from executing during its designated clock cycle. That means the most of the clock per cycle instruction should be CPI should be one only, but it's not possible here. Now type of hazards, there are 3 types there. One is called data hazards, another one is structural hazards, and another is control hazards. This session we are going to see the outlines and some of the example. Remaining we will see in the upcoming session one by one elaborately with the example also, possible real-time example. Now we have to get idea about data hazards. Data hazards the one acquire when instructions that exhibit data dependence and also modify data in different stages of a pipeline. That means what you can say means the data hazard arise before execute. Suppose we are executing 2 instructions, instruction 1 and 2. Before execute the instruction 2, instruction 1, the instruction 2 try to execute it. So the time some conflicts will arise, and how to solve it we'll see in the future classes. Now hazard cause, why we bother about hazard in pipelining? Because this always cause delays in the pipeline. Instead of CPI is equal to 1, it take 2 or 3 also, 3 seconds, something like that. And there are mainly 3 types of data hazards will be there. One is called RAW, that is read after write, where you can say true data dependency, and another one is called WR, write after write, another one is the write after write. So write after read where consists of anti-data dependency, and also write after write having the this is write after read, this is write after write. This is called output data dependency. Upcoming sessions will see clearly. Just go for examples. And now we have get about structural hazard. What is structural hazard? A resource conflict is a situation when more than one instruction tries to access same resource in the same cycle. And also a resource can be a what? Register memory or ALU, or you can say more than 2 instructions or multiple instructions want to say access the same resource. And then control hazards. This type of hazards occurs during the transfer of control instructions such as branch, call, jump, and etc. On many instruction architectures, the processor will not know the target address of these instructions when it need to insert the new instruction into the pipeline. So don't get confusion. Now I go for say the examples, you can will get clarity. So before seeing the structural hazard, we will go for another mode for raw, right after read. So let's assume that I want to execute the instruction called instruction 1 and instruction 1 consists of R2, then R2 plus R3, and instruction 2, so instruction 5, instruction 2 I have R5, R2 plus R4. Now let's consider the pipelining, 5-stage pipeline you already discussed here. Phases with what? Instruction fetch, decode, opcode fetch, execution, and memory stored in the memory, at last write back the result. That means back the result, write back the result and save in this R2 here. Similarly, this I2, this I1, this I2, and take the clock cycle of 1 to clock cycle 1, clock cycle 2, clock cycle 3, clock cycle 4, and clock cycle 5. In pipelining what happens? Whenever before completing the entire phase, we can start the another instruction. For example, you are going to instruction 1 starting, Whenever starting instruction 1, after completing 1 or 2 pages, you can start with 1 page, you can do the I2. Whenever do I2 having some pages, you can start immediately I3 and so on. So here listen carefully. So here R2, first we want to write first instruction R2, R2 plus R3. So I want to execute the I1 instruction here. What happen? It will fetch the instruction and the operand code will be there, execute it, and the memory take the result, at last write back result to the R2 Now the problem is what? In the I2, whenever the completion of first instruction fetch and decode here, it go and start the second. Whenever the it's one, what happen? So when you will get the R2, here we are accessing the R2 again, listen carefully. So when will your R2 result will come? After complete this write back only. After completing write back only, you will get the result of R2, then you can access. But in the pipeline, what happened? In the I2, the second instruction also want to access this. Whenever come this stage, the R2 want to access the result of R2 here. R2 want to access the result. So what will happen? The conflict arises is what? It give the wrong result. So whenever happen like this, in the read after write, it will give the wrong answer. Again repeating. First of all, in this pipelining, R2 want to execute. So R2 plus R3 is there. When will the operation, this arithmetic operation completed means after coming this W write back only completed, and the result will be stored in the R2 here. But same time what happened? The instruction 2 also want to access the R2 value when in the stage or phase of code here. So it will create the conflict, and definitely if you take the R2 value, it gives the wrong answer. This is the way you can understand about the read after write and how to solve. The upcoming session will see. Let's back to the PPT. Now we see the structural hazard here. So the structural hazard, just now I told you, more than 2 instructions or multiple instructions want to access the same data, same resource. Let's assume that we have instruction cycle where I1, I2, I3, I4 and clock cycle 1, 2, 3, 4, 5. Here what happen means same. Let's assume that you have 5 phases. Okay. Instruction, fetch, decode, execution and memory and so on, and like that will be there. Here what happen means, here you can understand. So keep on executing the pipelining instruction 1, instruction 2 and 3 and 4. Here in this above this problem, the table what happen means, whenever the instruction 1 execute the memory stage, in the same time I4 also executing. Here I4 also, instruction 4 also want to access same resource, that memory. So these kind of things introducing the resource conflict. I am again repeating. In this, whenever the pipeline start to execute the instructions, I1 after I1 completing, I2 started, and I2 complete before completing the stage here, I3 started, and I3 before completing, I4 will started, no issue. But the problem is both in the whenever come to the cycle 4, the instruction I1 and instruction 4 both are trying to access the same resource here. So it will give the conflict. How do you avoid everything? We'll see in the upcoming session. Now we go for next one. Very interesting and easy. So we already discussed about the registers, PC, program counter, everything in the previous sessions. Now consider that I want to execute the instruction in the program called where 100 in the I1 instruction 1, 101 in the I2, and this is the instruction I have structure 102 I3, at last 250 BL1, that is branch jumping. So here after I2 I want to execute jump 250 means what? It have to leave this I3 and move to the 250 here. This is a general one. But whenever try to execute this instruction in the control hazard, okay, branch sum, what is the problem happening means I am saying here. So let's assume that you have instruction 1, 2, 3 and branch 1 here, branch address instruction 1 here, where IF, ID, EX, M memory and write back. You have 6 stages here like that. So here what will happen means, after the PC will start from what? 100, 102, what happened? 101, 102, 13, 103 and so on. So now we want to jump means what? After this I2, I have to flush this remaining I3 and execute this 250 BL1 only. But here, whenever pipeline, this control hazards, what happens means it never do is some problem arising. So conflict arising, what happens is it execute the I1 and the I2. After executing I2, it will go and execute. I colored in the different color. It will execute the I3, wastage of time. After only it will go to the B1 branch instruction. So here what your expected output means I1, I2, B1 here. So I1, I2, I3, BI1, that is branch instruction. but we are getting the output signals in the form of I1, I2, I3 and BI1. So even the PC always monitor the next address, execution of address like that. So this is the problem arising in the controller side. So it keep on execute I2, after I2 instead of BI1 it execute I3 also, and waste and have some extra time. So these complexities to be avoided and overcome the problem of pipelining concept of controller sides. So I hope that you idea about what is pipelining. Already told you what is hazard and why hazards make delays in the pipelining, and types of hazard like structural hazard, data hazards and control hazards. If you have any queries or comments, please kindly communicate within the social media. And thanks for watching this video. Please like, share, comment, subscribe and press bell icon for more updates. Thank you.